Hey everyone, welcome to this week's lecture for Sound Design and New Media. This week's lecture topic is Generative Sound Design. What are we going to cover in this video? In this video we're going to talk about the role that generativity can play in the sound design of digital media works. So this can range from video games through to physical appliances, creating sounds to support, for example, user interaction. In this lecture we're going to be talking more about digital or virtual media experiences. However, with a little bit of imagination, you can see how this might apply to physical appliances as well. What is generative sound design? Great question. Generative sound design exists with a bit of an overlap with fields into generative art, and there are also other existing systems which look at generative engineering practices. However, for example, we could look at Galanter's description of generative art to get a good idea of what we are talking about when we use this word generative to describe the process of sound design. So generative art refers to any practice where the artist or designer uses a system, such as a set of natural language rules, a computer program, a machine, or other procedural invention, which are set into motion with some degree of autonomy, contributing to or resulting in a completed work of art. Great. How does that apply to us as sound designers? So, if we're working on a sound design and there is an aspect that of the creative process where we want to describe some rules, for example, of how it's going to work, but we don't want to, say, create every single possible permutation of how those rules work, we could apply a generative process to create all those permutations following that set of rules that we've described. So we would have been applying a generative process in our sound design. Now, in this definition, Galanter also implies that we could set out rules that create the entire completed work as well, not just a part that we're going to use within the sound design. So there are two general areas of sound design that we might consider in terms of generative structure, generative sound design. So this is generation of structure, which is talking about larger scale construction of a sound design project, and the textures that we might be working with. So, for example, these might be individual sounds, or you could probably but these are very much describing two different sides of a continuum. So, textures are talking more about sound, like individual sounds, individual components that we might be working with, whereas structures is talking about the overarching progression throughout the sound design. You can make an argument, this is very much a subjective continuum, where you could make an argument that, for example, the note on a piano might be a texture, might be a sound in this design, and you're arranging it into a structure, which, to go with the analogy, could be a piece of music, which in and of itself could have multiple underlying elements, structural elements that are arranged together. So the individual sounds and textures, they are building blocks, and these we could consider as, if we were generating these individual sounds, we could consider this as a low-level process of generating sounds. So if we consider, as we discussed earlier with pattern language, if we were to represent how to make a sound design in pattern language, if we were employing a generative technique for creating these low-level building blocks, they would exist further down on the pattern hierarchy than the structure, which would be sitting higher up, because that's how you arrange those individual components of the sound design. So high-level processes of generation is the process of organizing these textures. So, for example, if we were to organize these textures, typically we're going to have to employ some system that either uses metadata, so information that we've given the system, or you as the sound designer have given the system for the organization of those blocks, those textures, or it might employ a process of analysis to for example, pull out, what's the spectral centroid of this sound? What's the let's look at the FFT analysis, or how loud is this sound? We might consider as well. How fast is the attack? So you may employ a process of analysis to understand more about the sounds that you're working with in this process. So let's look at some examples of high-level generation. Proteus is a game created by Twisted Tree Studios, Ed Keyes and David Kanaga, and it provides a very concrete example of a process called emergence, or a process we could classify as emergence. So in the game world, all the entities have a looping sound that iterates over and over again, and the volume of that sound is controlled by the proximity of the player to that entity. So as the player moves throughout the game world, they hear a different combination of sounds. And as entities move around the game world, moving towards or away from the player, that can also affect the mix of these loops. So the sound design experience here emerges as the player interacts with the game world. Now, to look at something a little bit more complicated in terms of analysis, a very interesting example is narrative-inspired generation of ambient music, which is a paper describing a research project by Sarah Harmon. And in this project, the generative process is given the input of a script or a block of, or a descriptive text of a scene. Now, in this case, this is narrative inspired. So the sound design analyzes the text that's been given, pulls out thematic content from that, and then, in a process almost similar to our tutorial last week, it goes and searches libraries like Freesound with keywords that have been inspired from that text, and assembles a sound design. Now, as it's assembling those samples, it also employs some analysis techniques, such as looking at the dynamics of the sound, or pulling out, for example, the spectral centroid to find harmonious sounds. So this process of inspiration from text to analysis and arranging this information creates a complete soundscape purely from this inspiration. So this would be an example of generating high-level generation. In this case, it hasn't generated the individual sounds themselves. In this case, it's being smart and searched a database for them instead. But it has performed this process of assembling and arranging everything together. So, talking about low-level generation now, we could consider a very interesting example, which was No Man's Sky. So in this game, so let's think about the problem here. So they're performing, in this game, there are procedurally generated creatures. So there's a process of combining different features of these alien creatures together, and they had to come up with a system that could create iconics, or create the sounds for each of these creatures. And so there's the combinatoric system, which is putting together the creatures you see, but there's also combinatoric systems sitting behind this that build the parameters that are fed to the sound design and the sound engine to create these sounds. So in this particular case, they have a set of samples sitting underneath this, and there's also then audio manipulations that sit on top of that. And so different creature phenotypes, as they refer to it in the presentation, provide, that I've linked down there, different creature phenotypes provide different base waveforms, but then there's also the variations on the shape, the size, like the length of the neck, the nose, things like that, that influence the modulations that are also applied to that foundational sound design. So this takes the problem of how do we create thousands, possibly even hundreds of thousands of different variations of these sounds. And means that you, instead, by working with these rules, you can generate these individual building blocks that can then become part of the broader soundscape of the game world. So you probably picked up a couple of these ideas, but let's quickly discuss as well, just finishing up, what some of the motivations for generative sound design might be. So for example, you may employ this for automated prototyping. So for example, if you had a system like the narrative-inspired sound design engine, you could use that for creating a prototype soundscape for a level or a scene in a movie. You could apply that in all sorts of different settings like that. In the same way, if you had a voice synthesizer for creating different animal sounds, you could potentially use those high-level parameters that you set up there to discuss, also to create prototypes that are closer to the sounds you're working with. This also then ties in with procedural content generation. So that is a general field within particularly video games that looks at applying generative processes to create content in games. For example, a very throwback example, the original Diablo game had combinatorically generated levels. And that was and this was also very common in roguelike genres as well. So tying in sound design, as for example you see in No Man's Sky, is just another aspect of procedural content generation in video games. So diving into some more interesting design topics, this also can tie in with integrating complex parameters for auditory feedback to a user. So for example, if you have a very complicated, if you have a more complex number of parameters, it may be easier to do synthesis in real time rather than just grabbing individual waveforms, so that you can manipulate the sounds in more precise ways to give the user more information about what is going on. This is particularly true if you have continuous parameters rather than your thing turns on, thing turns off. If you have a range of values that you're trying to communicate to a user, this can be quite useful. For example, you might have, an example of that would be the acceleration values in the autonomous vehicles assignment. That would be an example of a continuous value. So otherwise, there are also opportunities in terms of overcoming challenges relating to repetition. So both repetition in terms of an industrial environment or medical environment. So how do you potentially manage the challenges around alarms sounding the same and people tuning them out, but also very much so in virtual environments, creating ways that modulate sounds over time is a very common and useful strategy to try and maintain immersion for a player in a video game or other virtual environment. So this is another aspect where generative sound design is quite useful. So that's all for this week. We'll see you guys in the tutorials, and hope this was informative and useful. Any questions? Let me know.